Hello, did you know that 50% of the stars that you see in the night sky have a partner? Just like the sun and the earth move around each other, the same thing happens with stars in the sky. And just as life can be quite simple when you're by yourself, when you have a partner, things get a little bit complicated. My name is Abdul-Masih, and I am a fellow here at ESO, working at the European Observatory. I'm in charge of UT3, which is this big telescope right here, and I'm happy to talk to you guys today. As far as binary systems go, when you have two stars that are evolving together, there can be a lot of interactions that happen between the two stars. We have a fairly good understanding of how a single star evolves. But when you have a partner with that single star, there can be a lot of interactions between the two, whether it's gravitational interactions with the two of them getting so close that they distort each other and are no longer spherical. You can also have mass transfer, so one star that gets a little bit too big and starts giving some of its material over to its partner. You can also have them combine if they get too close. So instead of just transferring material from one to the other, if they get too close, they can actually spiral in and merge and form a single star. And all of these things can really affect how we understand stars in the sky. Considering how many of them are in binary systems, if we just look at a star and we aren't sure whether it has a partner or not, and we try to make inferences on how the star has evolved, how it's gotten to this point, and how it will continue to evolve, then we may be coming up with the wrong interpretation of these systems. So by studying binary stars and by having a better idea of how these stars can interact with each other and how these interactions can affect the evolution of both stars in the binary system, we can begin to understand and have a better idea of what to look for to see whether a star has been born single or has merged in its past with its companion, and how all of this affects its future evolution and what we expect the star to turn into when it finally ends its life. So specifically, I am interested in a very interesting class of binary star systems, and they're called overcontact binaries. And these are stars that are so close and so massive that they are sharing material between them. So they are kind of shaped like a little peanut. And this is what we think to be the last stage before the stars actually merge, where they're so close, they're sharing material, they're going around each other very, very rapidly. And there's a lot of very interesting physics that happens when you have stars in this configuration. Depending on the internal processes that are happening and the internal physics that's happening within the stars, we have several different theories that tell us what these kinds of systems will turn into. So for example, if they're mixing very, very efficiently, then we think that these contact binaries may turn into double black hole systems and form gravitational waves. Alternatively, if the processes inside aren't quite as efficient, if the mixing isn't as efficient, then we would expect the stars to merge together before they collapse into black holes. So then we can form things like BE stars, which are very, very rapidly rotating stars that have a disk of material that is around them. So my specific research is trying to understand the physics that's happening on the interior of these stars while they're still in the contact configuration, because this will allow us to have a better understanding of whether the stars will end up as black holes, or end up as BE stars, or end up as any other type of outcome. All right, that's all the time I have. It's sunset, so I need to go and get the telescope ready for the night. So thank you very much, and it was great talking to you.